Hey everybody, we are going to begin a review of some basic trigonometry, and we're going to split this up into 4 videos. In this first video, we are going to talk about finding all 6 trig ratios. So here, we want all 6 trig ratios for theta, and we want our answers simplified. Now, in order to do this, we need to know the length of this hypotenuse. So we're going to use the Pythagorean theorem, 12 squared plus 16 squared equals c squared. So in our calculator, we've got 12 squared plus 16 squared is 400. So 400 equals c squared, and the square root of 400 is 20. So we've got 20 here. So we need sine theta, cosine theta, tangent theta, and their reciprocals, cosecant theta, secant theta, and cotangent theta. Sine is opposite over hypotenuse. That is 16 over 20, and 4 goes into 16 and 20 4 times and 5 times. So 4 over 5 is the simplified answer. Cosecant is the reciprocal of sine, so that will be 5 over 4. Cosine is adjacent over hypotenuse. That's 12 over 20, and 4 goes into 12 and 20 3 times and 5 times, which means secant, the reciprocal of cosine, is 5 over 3. And then tangent is opposite over adjacent. That is 16 over 12, and 4 goes into 16 and 12 4 times and 3 times, which means cotangent, the reciprocal of tangent, is 3 over 4. Next, we are given the point -9, 6 on the terminal side of an angle. So -9, 6 means we're going to go 9 to the left and 6 up, and our point will be right about here, -9, 6. Okay, so there's our angle, and -9, 6 is on the terminal side. Find all 6 trig ratios. So our reference angle is right here, so this is theta. We've got -9 here, we've got 6 here, and we're going to use Pythagorean theorem to find the hypotenuse. So that's 6 squared plus -9 squared is c squared. Okay, so 6 squared is 36, -9 squared is 81, so that's 36 plus 81. That is 117. And we take the square root. Now, 117 is not a square number, but I believe 9 goes into 117, and here's how I know that. 7 plus 1 is 9, and the sum of the digits being 9 is divisible by 9, so that means 9 will go into 117. So it's 9 times something, so 117 divided by 9 is 13. So 9 times 13 is c, the square root of 9 times 13. The square root of 9 is 3, so 3 times the square root of 13 is the hypotenuse. So now we need the 6 trig ratios: sine theta, cosine theta, tangent theta, and then cosecant theta, secant theta, and cotangent theta. Sine is opposite over hypotenuse. That is 6 over 3 root 13. Okay, so let's just simplify the 6 over 3 right now. So we're going to start with 6 over 3 root 13, but I'm going to simplify 6 over 3 to 2 over 1. So it's going to simplify to 2 over 1 times the square root of 13. Okay, now cosecant is just the reciprocal of that. That's the square root of 13 over 2. But I'm not really done with sine. I need to simplify this by getting rid of the irrational number in the denominator. So I'm going to multiply the numerator and the denominator both by the square root of 13. And I'm going to get 2 times the square root of 13 over 13. Cosine adjacent over hypotenuse is negative 9 over 3 times the square root of 13. So I know it's going to be negative. And then it's 9 over 3 times the square root of 13. But I'm going to simplify 9 over 3 right now. 9 over 3 is 3 over 1. So that's 3 over 1 times the square root of 13. Which means secant is negative square root of 13 over 3. But let's simplify this by getting the irrational number out of the denominator. So multiply numerator and denominator by the square root of 13. And we get negative 3 times the square root of 13 over 13. And then for tangent, opposite over adjacent is negative 6 over 9, which is negative 2 over 3, which means cotangent is negative 3 over 2. Okay, here we are given cosine theta is 12 over 13. Find the other 5 trig ratios. So we have sine theta, cosine theta, which is 12 over 13, that's given, tangent theta, and then cosecant theta, secant theta, and cotangent theta. Secant theta is the reciprocal of cosine theta, which means it is 13 over 12. Okay, so let's draw a triangle for this one. And we'll put theta here and say if cosine is 12 over 13, then that's adjacent 12, 13 hypotenuse. And we'll find this missing leg. 12 squared plus the other leg, we'll call it b squared, equals 13 squared. So to get b squared by itself, first I will subtract 12 squared. And then I can do this in my calculator. 13 squared minus 12 squared. Try that again. 13 squared minus 12 squared is 25. So that's really 169 minus 144, which is 25. And then the square root, and 25 is a square number. B is 5. So sine, opposite over hypotenuse, is 5 over 13, which means cosecant is 13 over 5. Tangent, opposite over adjacent, is 5 over 12, which means cotangent is 12 over 5. And last for this video, tell whether sine, cosine, and tangent are positive or negative for each quadrant of a coordinate plane. So here is a coordinate plane. And I want to know for sine, cosine, and tangent for each quadrant, it's going to be positive or negative. So in the first quadrant, sine is opposite over hypotenuse. That's y over some hypotenuse. That's a positive over a positive. That's going to be positive. The adjacent for this reference angle, theta, is the x value over the hypotenuse. Those are positive numbers also. And tangent opposite over adjacent is positive over positive. When we get into the second quadrant, our reference angle here, theta, we've got a negative x value but a positive y value, and this hypotenuse will always be positive because as we did up here with a negative when we squared it, it ended up as a positive. So we will always have a positive hypotenuse. Sine opposite over hypotenuse is positive over positive, but cosine adjacent over hypotenuse is negative over hypotenuse. And tangent is a positive over a negative, which is a negative. Then in quadrant 3, I've got a negative x and a negative y, but still a positive hypotenuse. Opposite over adjacent is negative over hypotenuse. Opposite over hypotenuse is negative over positive. adjacent over hypotenuse is negative over positive. And for tangent, opposite over adjacent is negative over negative, which is positive. And then into the fourth quadrant, I've got a positive x, a negative y, and the hypotenuse is always positive. Sine is negative over positive. That's negative. Cosine is positive over positive, and tangent is negative over positive.